Okay, so I would like to welcome everybody to GPUG. Let's talk about our agenda. First things first, I think I want to cover what is a service container. Naming is really hard in software. And so like what I refer to as a service container might be different from what you think is a service container or what somebody else thinks is a service container. So for the purposes of this meetup, I want to say, what is a service container? Why is it even something that exists? Why do we even need them? Following that, once I've convinced you, we're going to say, how does a service container actually work? What are some of the concepts? We're going to talk about building it, and we're going to build it in a TDD kind of sort of way. It's going to be similar to something called an exorcism. If you go to exorcism.io online, there are all these like little programming challenges, and your job is to make all of the tests in the test suite pass. And that's the way that we're going to be approaching this today. First question, what is a service container? All right, so a service container, in my definition of this is what I put together, is a tool which ideally lives within your framework of your application, whose responsibility is to provide access to services needed by that framework. So scratch your head to whatever. Let's break it down a little bit. So when I say that it's a tool, it's just another part of your application that you get to use, right? And tools are supposed to provide some sort of functionality. And the functionality that this tool says is, hey, if you need a service, I can give it to you. And we want it to live within the framework. And so we don't want it to kind of like bleed its way into your business domain, into your domain objects, those sorts of things. If we're thinking about like a web framework, we kind of want it to live in like the controller sort of, like that's about as deep into the application as we want the container to go, is into like the controller. It can live anywhere between the bootstrap and that point, but I really wouldn't want it to go anywhere below your controller. Okay, so that's why I mean by ideally lives within the framework. That's what I'm calling a service container. I hope it was as confusing to you as it was for me to explain. And then, so what's a service then? Okay, if a service container is something that contains service, what is a service? Continuing on the vagueness trend, a service for the purpose of what I'm going to be talking about is something that does something. So that can be a class that talks to a database. It could be a class that talks to an API. It could be something that logs to a file, or maybe something that logs to a database, or maybe it could be something that talks over WebSockets. Something that does something. That's basically what a service is, and a service container is a container for those things. Why can't the framework just get the services directly itself? Why do we even need a service container? Like, why do we need this tool? When we adopt something, we're paying a price, pay a cost for things. That's not different when we talk about service containers. If we choose to use one, we're going to be adopting a certain cost. So what is the benefit that we get from it? For me, that's flexibility. It's the ability for us to say, well, you know, if we wanted to talk to a database, that could be a MySQL database, or it could be a Postgres database, or it could be an SQL server. If we wanted to talk to a log, it could be a file, it could be a database, it could be a SaaS, something along those lines. And then so a service container allows us to have that flexibility in our application. The way it does that is by implementing the fundamental theorem of software engineering. It allows us, which says basically we can solve any problem by introducing an extra level of indirection. So what does indirection actually mean? Indirection means we can reference something through the means of something else. In the terms of like a service container, let's say we want to talk to our database. We can have a database, like a MySQL database manager, but we don't want to actually reference it as the MySQL database manager. We want to call it by the database. So we can say, hey, give me the database, and it gives us that thing. And that gives us the ability to kind of swap things in and out. So if we want to talk to a MySQL database or a Postgres database or something like that, the service container allows us to do that. So how does a service container work? For me, it's a mashup of some similar but different concepts. So it's a matchup of the dependency injection pattern and the service locator pattern. So I want to show us a couple of examples of what that actually is. I can talk about dependency injection. Let's jump to some code real quick. So this is an example from a blog post that Martin Fowler wrote back in 2004, where he talked about inversion of control and dependency injection. We can see here, this is a movie lister. One of the things we see is like, so to set up the scenario, a person has a movie lister. So they have a library of movies, like they have all sorts of DVDs, and they have like their database for that in a file called movies.txt. And their movie lister has the ability to hand back a list of movies that are directed by a certain director. And so this person has this, and they find it very useful, and they want to share this with somebody, and they want to share it with their friends, and they say, okay, hey, I've created this great service that allows you to list out movies that you have in your own library. What you have to do is you have to have a file called movies.txt, which is :delimited. That's what the movie lister will read. And they might hear back from their friends who are like, well, actually, I have my own copy, like I have my own database of movies that I keep, but it's not in a :delimited file, it's in something else. They have to find out a way to kind of like configure their own system so that it works. And so dependency injection is what we're talking about right now, is a way of injecting the things that the class actually relies upon. And that's either at construction time or through setters. So you can see here in the constructor, what we've got is this finder equals new :delimited movie finder. One of the things that we can actually do if we wanted to, so this is a concrete implementation that this finder is. But if we want this finder to be an implementation of something else, something that talks to a database or something like that, we have to find out a way of how we can enable that. And we can do that through constructor injection. And that's basically what we mean by dependency injection. So what we can do at this point is we're going to call this finder. Okay? And then when that gets passed in, we can have this outside of here. Let's just say we're going to instantiate this. We're going to say, let's just say this is our lister, and it's going to be a new movie lister. If we didn't have the ability to inject the finder, we'd only ever be able to use the :delimited movie finder. But through dependency injection, if we wanted to inject it at construction time, all we can do is we can just say new :delimited movie finder movies.txt. And then in here, we would say finder, and this is equal to finder. All right. And that's effectively dependency injection. That's all that is. If we wanted to have a setter for that, we can do that as well, just by having a setter where we say set movie finder. And then at that point, once we have our movie lister, if we didn't want to actually have the finder in here, so we could set that to null, and then it's not constructed with it, we can extract this to a variable, and then we can delete this. And we can say lister finder, and then just our :delimited movie finder. And that's setter injection. So that's basically in a nutshell what dependency injection is. And the service container makes use of that in order to construct objects when they're asked for. The container also understands what a requested's dependencies are, and it knows how to build it. And it can do that either programmatically or via reflection. And a really important part about the dependency injection as it relates to the service container is something called lazy evaluation. So you can register a lot of services with the container, but you don't want them actually being constructed when you register with them. You only want them to be constructed when they're asked for, because it can be a lot of upfront costs that you don't actually have to use, especially in something like a PHP web framework where every single time the entire world gets built up and torn down for every single request. So service containers are also make use of a pattern called service locator. And in this instance, the instances of the classes are registered with the locator. The difference there is that they're actual instances of the class. They're not kind of like recipes on how they're built. They're actual full-fledged and real instances. Those classes can be accessed statically through the locator. So if we went back to our example here, one of the things that we could do is if we had a service container for it and we wanted our finder, we could say to the service container, we could say, hey, container, get me the movie finder, right? So it would just be a movie like called movie finder. And then we could have our container that has a method, a public static function called movie finder. It just returns our new :delimited movie finder. And that's basically how that works. and that would be service location. Hopefully I've done an okay job of explaining to you kind of what a service container is. So in a nutshell, it's something that we can put things into and get it out of. One of the things that a service container does for us, so these are the feature set actually that I want to be able to provide with my service container. I want to be able to register services. I want to be able to access the services that are registered with my container. So I want to be able to put things into it, and I want to be able to take things out. I want to make sure that I can access those services statically. So similar to what I just showed with the service locator, I want to be able to say, give me the container, give me this part of it. I want to be able to support lazy evaluation. So I don't want to have to evaluate every function that gets registered with the container. What I want to be able to do is only evaluate it when it's asked for. I want my container also, this is some of the fun part, is I want it to be able to create classes that aren't actually registered with it. So if it's asked to get something that it doesn't have it actually registered, but it's a class, I want it to be able to construct that class. Also, part of that construction, I want it to be able to auto-wire the classes that it's constructing together. So I want it to be able to resolve the dependencies of classes that it's being asked to make, and then construct those and then send them back. Another thing that I think is really important for the service container is for it to be able to register shared services. Think of these like singletons. So I want it to have the ability that when I ask for, let's say, my database connection, I want it to be able to, every time I ask for it to give me that database connection, I want it to get the same one every single time. And another thing that I really like it to be able to do is register something like factory functions. So I want to be able to register a function with it and then ask for that function back so that I can then invoke it. So this is the feature set that we're going to be building with the service container. I think we've made it this far, so thank you very much. And I want to start building this. Okay, so let's get into some code. I'm going to show us our tests first. So that's what we're going to be doing, is we're going to do this in a test-driven way. I'm going to look for our container test. And so this is our container test. And so this is what I was talking about in terms of like the exorcism type approach. You can see here that we have all of these tests already written. It can be created, it can register services, it can get services that are registered. This is a long one. It throws a not registered exception when getting something from the container that isn't registered. It can be a singleton, so on and so on and so on. Now, if we look at this one, we can see that we're just going to assert that this is a null so that we can actually create it. All of the other tests, though, are actually skipped at the moment. So if we were to run this test suite, we're only going to run this first test. And then as we get that one to pass, we're going to unskip the test, run it, and then make it pass. So the first thing that I want to do when I'm writing my container is I want to make sure that I have a test suite that runs. One of the things that I've done for PHP Storm, this is what I'm using, is I've installed a plugin called a Presenter Assistant. So you'll see as I use my keyboard shortcuts, a little window shows up that says, this is the keyboard shortcut that I used. So let's start by running our tests. We ran our tests and we have one failure right now, 17 ignored. And we can see that the error was the class injector container is not found. Let's go to that test. And this is it here. And we can see the PHP Storm is actually telling us something here when we say container. And then so when we go here, it's telling us that that class doesn't actually exist. So undefined class container. So I'm just going to create that class now, and that's going to make this test pass, hopefully, right? And so it's going to ask us, where do we want to put it? I don't want to put it in the test directory. I'd like to have it in our source directory. And then we're just going to let that go. And then do I want to add this to Git? Yes, I do. Thank you very much. And there we go. We actually don't need a constructor at this point, so I'm just going to delete it. And then I'm going to allow our test to run again, and hopefully it passes at this point. That's good. So we got one pass test and 17 ignored. So let's go to the next failing test. And that's, well, the next skip test, and that's that it can register services. So we're going to unskip this test, and we're going to run our test suite again. So it failed, call to undefined method, injector container register. At this point, we're running the test, it can register services. And so we ran our test and it failed, and it said that it failed because we have an undefined method, register. So register is going to be the method that we're going to use to register services with our container. The structure is we're going to register the name foo, and it's going to be the service. At this point, it's just a string literal that says this is foo. So we're going to put something into our container is what register actually does. So we're going to implement that method right here. And again, like I said, I want to change the parameters. So this is going to be our name, and this is going to be our service. Right. And one of the things also that I want to try and do for here is I want to make use of return values or return declarations because I don't normally do that. And I want to use this as an example of doing that. So now this is going to return void. Now that we run it, we got a new failure again. It says call to undefined method registered. And that's in our test here where we're writing our assertion. So what we want to do is we want to make sure that, hey, is foo a registered service? So that's what assert true is going to do for us. So we're going to go ahead and we're going to implement that method again. And it's here. And we want to call this name. So we're going to run our tests again. This is the TDD part of things. And right now we're failing for a good reason. We're saying that null is true, failed asserting that null is true. And so we can see that here. This is again in our test. We're going to assert true, injector registered foo. Now we've got a void method. Yeah, so let's go to that method here. I forgot the return type. We want this to be a Boolean. And so we actually want this to return true. So why don't we just make it do that? And you might be thinking to yourself, well, that's kind of silly. But at least we're green now. So the test is green. And now that we're green, we can do that red-green refactor part of our test cycle. So now that we're green, we can refactor this code so that it actually does what it needs to do. So let's start with registering. So registering right now is an empty method, so it doesn't actually do anything when it's called. If the service container is going to be something that contains services, we've got to have a way of holding on to things. And so why don't we have an array called services? I mean, it makes kind of sense to me, and it seems like the simplest thing that we can do right now. So I'm going to do that. So I'm going to say this services. And it's going to be an associative array equals service. And I'm going to add this as a property. And so private's fine, and it's going to be an array. And we're going to initialize it to be an empty array. Now, to see if something is actually registered, what I'd like to do is just check to see if that name is a key in our services array. So we can do that with array key exists, and then that goes by key and array. It's always so hard to tell what is the order of the parameters. So looking for name in this services, all right? And now that I believe that I think we've written enough of this code that we can run them again and see if we're still green, I think that we've done a good refactor here. And sure enough, it looks like our tests are green. All right, so let's move on to our next test. All right, and so this is a test called it can get services that are registered. So we've gotten past the point where we can register services. Now let's see if we can get them actually out of the container. So let's run our tests, and I anticipate that this is going to fail. And again, it's going to fail because we actually don't have a get method on our injector. And so get is going to be the method that we're going to use to get those services out of the container. Well, why don't we just implement that again? Here we are. And we're going to be getting the service by its name. So I'm going to call it name there. Unfortunately, this can return any number of things. I can't put like return mixed. It blows up at me for doing something like that. So I'm going to add a PHP doc so that we can say that, hey, this returns mixed attribute. So I'm going to run this now, and our test failed. And so we failed asserting that null matches the expected this is foo. So if we look at our test, I just want to make sure that we're reading it. Our test, what we do is we create our container, and then we register foo with it as this is foo. And then we want to assert that when we get foo from the container, that we get back this is foo. And right now, we're actually getting null, and we're not getting this is foo. So let's make that test pass. So let's go to our get method. And all we really have to do to make this pass is we're just going to return this services at name. So let's run our tests and find out where we're at. All right, and I believe we're all green for now. So that means that it can get services that are registered actually works now. So that's because in our get, we're just returning services at the name. So the next thing that we want to implement is this test here. It throws a not registered exception when getting something from container. I guess that should be the container that isn't registered. So let's walk through this test and make sure that we understand what's going on. So for this test, we're expecting our container to throw an exception. We were expecting it to throw a not registered exception, and we're expecting the message that's going to go along with that exception to say, not registered is not registered with this container. So this is kind of like our setup phase of our test, and this is going to be our acting phase. So there's no assertions because our setup is also our assertions, our expectations. We're going to instantiate our container, and then we're not going to register anything with it, but we're going to ask for something called not registered. And so hopefully that's going to throw an exception. What does it do right now though? So it did fail, and we got class injector not registered exception does not exist. So that's what PHP Storm is telling us here, saying, hey, this isn't defined. Let's get this test so it at least runs and we get a real error out of it. So we're going to implement this class, and we're going to make sure that it lives in our source directory. Okay. And we're just going to say, okay, make that for us. We're going to add it to Git, which I haven't made a commit yet. I'm a bad developer. I should probably made 4 or 5 commits already. So this is going to be an exception. And so what I wanted to do is I wanted to extend something like a runtime exception. And now let's run our test again and see what kind of error we get. So now what we do is we get an undefined index not registered. And that actually gets thrown here in our test where we're trying to access not registered here. And that doesn't actually exist in our services. And we want to stop before we get to this point. We want to throw that not registered exception. Okay. So in order to make our test pass, what we're going to do here is we're just going to check to see, hey, if it's not registered, then I want us to throw a new not registered exception. That's it. So let's run our test and see where we're at now. So we have a new failure, and it was failed asserting that message empty string contains not registered is not registered with this container. So all exceptions in PHP have a message associated with them. And right now there's no message associated with this exception. It's just an empty string. So we want this exception to have that message not registered is not registered with this container. What I'm going to do that is I think because we're asking for not registered here, our name, I'm going to pass that into the constructor of our exception. And then I'm going to go to its definition and I'm going to add that constructor. I'm going to format here. So because this extends runtime exception, it's going to call the parent constructor. And again, you can see message here defaults to an empty string. And that's why we're getting an empty string here. So we want this message to actually be this here. So I'm going to do a little copy paste here. I'm going to grab this. I think that's all I want. And we changed our constructor to include the name of the service. So that's a string name. And then we want to be able to construct our message. I don't really care about code in previous. So we're going to say message is equal to, we're going to kind of like cobble this together. So it's, instead of not registered, this is going to be our name. All right. So what this is actually going to do is it's going to say, it's going to make message equal to whatever the name is not registered with this container. And then it's going to call the parent constructor with that message. So let's run our tests and see if we're passing now. And we are, which is great. So we were able to make that test pass. So now this is passing for us. So what's our next test? It can be a singleton. So this is related to that service locator part or pattern I wanted our container to be able to have. So I wanted to have a way for us to access it as though it was a singleton. A singleton is a class that holds an instance of itself that when you ask for that instance always gives you back that same value. So what does that actually look like? Let's run this test. So we failed here. And the reason was it was a call to an undefined method container injector. And we can see PHP Storm is telling us that already. So let's implement that method. And you can see here that it's a public static function called injector, and we're going to have it return a container. All right. And in order to make, so if we were to run this now, we're going to get a different error. And it's going to say it's a type error. The return value of container injector must be an instance of injector container, and none was actually returned. So just to satisfy the parser, we're just going to have this return a new container. Okay. And let's run our test and see where we're at. We have a new failure. and it was failed asserting that the two variables reference the same object. So this is this assertion here. So what this is asserting is that when we call injector multiple times, we get the exact same instance back. And right now that's not happening, because every time we call injector, we get a new instance of the container back, and that's just not a singleton. So whenever we call this method injector, we want to get the exact same instance of our container back. And so we need to make it do that. This is a very common pattern. So the way that it works is we keep reference to an instance of this class inside it in a static variable. And so what we're going to do is we're going to say if self instance is null, then we're going to instantiate this instance. So let's add this as a property, and it's going to be nullable container. And then so if that instance actually is null, which it is until this method has been called, then what we're going to do is we're going to instantiate an instance of itself and store it in that instance variable. So that looks like this. We're going to say self instance equals new self. And then we're going to return self instance. So this implements our singleton, right? Every time, if the first time we call this, instance is going to be null, so we're going to instantiate it, put it in that variable, and then every other time that we call this method, instance won't be null, so we're just going to return it. So if we run our tests, we should pass now. And you can see that we actually did. Let's see what our next test is. This is the test that says it allows the singleton to actually be set. And so basically what we want to do is we want to allow anybody using the container to say, hey, this is the singleton that I actually want used. So you can see how in the test we're doing it, we're instantiating the container, and then we're calling a method called setInjector, which is what I'm calling my service container, and we're passing in that container. And now we want to assert that when we call the injector method, that we get this instance of the container back and not something else. So if we run that test, it's going to fail. And the reason it failed is because there was a call to an undefined method setInjector right here. So let's implement that again. Select function, and it's going to return void. Now we'll run our test again. And the failure this time is we failed asserting that two variables reference the same object. So you can see here, this is the assertion that failed. So when we called injector, we weren't getting this container back. And that's because setInjector really wasn't doing anything. Let's go to the definition of setInjector and make it do something. And what it's going to be doing is it's going to be setting the instance that we've got equal to the container. Now, if we run our tests, it's passing, which is good. So what is our next test? So this is something that's kind of interesting. So the test is it evaluates functions that are registered as services. And so this is going to tick off the lazy evaluation part of our service containers. So if we were to look at what we've done so far, we were able to register services. We're able to access our registered services. Services can be accessed statically. That was the singleton. The next thing we're working on is the lazy evaluation. What we're going to do here is instead of registering like the string literal, this is foo, or new class or something along those lines, what we're registering at foo is a function. What we don't actually want, you can see that when we get foo, we don't want this function back. We actually want the string, this is foo. So we want this to be evaluated when it's asked for. And that's the lazy evaluation part that we're trying to implement. So let's run this. Right here, we've got argument 2 passed to injector container register must be of type string object given. Well, that was just an oversight on my part. So let's go to register. And really what we want, because we're passing in a function here and not a string, this is complaining. It says, hey, this has got to be a string. We want a service to be able to be anything. We want it to be the mixed type effectively. So I'm just going to delete that. And I'm going to add some PHP docs here. I'm going to say that this is now mixed. PHP Storm is going to be able to say, hey, when we look at register, which it gets called a bunch of different places, but this is the first spot, I think. When we ask for the definition, it'll say, hey, give us name and string. Okay, so let's run this test and we'll see what happens. So it failed this time because it says closure object does not match type expected type string, which is right here. So this assert equals, this is foo, injector get foo. This is failing because actually what we're getting back when we see injector, or we can actually just debug here and we can see what we're getting back. I'm going to run this test in debug, okay? When we call injector get, this right here, so just so we're clear, I'm running the tests in debug mode, which allows me to set breakpoints. And so I can stop the actual execution of the script at any point, and then I can inspect to see like what these things actually are. It's a really powerful tool for figuring out what's going on with your code. So we have this little evaluator here. And then so I can pass in injector get foo, and we can actually see what we get back when we call that. And what we're getting back is a closure, which is that function. Let's put that into a variable and then see what we get back. So I think we can actually do this. I think that if I put this into foo like this, injector get foo, I wonder if this is actually going to work for me. No, I don't think it is. So just understand that this is actually giving us back this entire function. That's what we mean by closure, okay? And it's not giving us back this is foo. So I'm going to let this play through. And then we're going to make it so that, hey, if this actually is a function, we want to evaluate that and then store its value, okay? So let's do that. Let's go back to our get method. And it's right down in here. So we know that it actually is registered. And then so what we're going to do here is we're going to check to see, hey, if this service's name is callable, right? If it's something that we can actually invoke, then let's just invoke it and then return that, okay? So I'm going to return this service's name that. And I think that should do it for us. Now this is a little bit confusing though. This service's name, this service's name. I think what I actually want to do is I want to extract this to a variable. Let's just call it service for now. And let's replace, yeah, sure, all two occurrences. Let's just call that service. Okay. And so now, if the service is callable, I just want to return that. So I'm not sure why I didn't pick that up. And we're going to run our test now. All right. I think we're green. Yeah. And so now when we called that, let's go to that test. We're getting back this is foo, and we're not getting that function. And the reason that's happening is because if we were to go into our debugger again, so we're going to step over and we're going to get our service. And our service is this closure. And so it is actually callable. And then so we're going to invoke it here. And when we invoke that, we're going to get back this is foo. That's what's actually going to be returned from our container. And that's what I mean when I say lazy evaluation. I hope that's clear to everybody. We're going to let that play through, and our tests are green. Now I want to run all of our tests again, so I'm just going to make sure that we do that. So we're going to run PHP unit tests, and we're all green. So the next test that we've got to deal with here is this one here. So it passes itself into functions that are registered as services. And so if you're familiar with Laravel, one of the things when you use your service providers is you can bind things in the container, and then that container actually has access to the container inside the function. And that allows you to reference other things that have been bound into the container as well. And so basically we want to make sure that when this function gets actually evaluated, that it gets the container, right? That it has the container passed into it. So we're going to assert same that our injector is actually been passed into this function. So this is actually, I think this might actually be a little bit confusing. So let's just make sure that we're all on the same page. So we're going to construct our container here, and then we're going to register a service in it at the name foo, which is actually this function. So when we ask for foo to come back to us, we want to make sure that this function gets evaluated. We just covered that in this test here. So we made sure that function actually got run. Inside of this function is when we're going to do our assertion, because we want to assert that the container is passed into any function that actually gets run by the container. And so we're going to make this assertion that the container that was actually passed into this function is our injector here. Okay, so let's run this test and see if it passes. All right, so it failed. And so it failed asserting that null is identical to an object of class injector container. So actually nothing, this is null. If we want to run this in debug here, let's just skip this breakpoint. We can see here that container is actually nothing at all. So this function, when it was evaluated by our service container, wasn't passed anything. And so it's null, which means it's not the injector, so that test is going to fail. So you need to make it pass. And it's actually really, really straightforward in actually how to get it to pass. This is our get method. This is where we're identifying that, hey, this is a function that we're going to have to evaluate. And then so we're calling it here. And so if we want to make sure that we pass an instance of ourselves into these functions, all we have to do is do that. Just pass in ourselves. Now, if we run our tests, hopefully they should pass. Oh, this one tested. Here, let's run them all again. Sorry. All right. So you can see all of our tests so far have passed. Even the one that we were working on just now, it passes itself into functions that are registered as services. So just to make sure that everybody's on the same page here. Sorry. You guys going to bed? Okay. All right. These are my two youngest kids. Sorry. Good night. I love you.
Kid.
Yes, you are a kid. All right. I love you.
Love you.
All right.
Lord, you need to get out
All right.
here.
Out, 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 out. Bye, guys.
Pew.
Okay. Yes. Thank you. Bye.
Pew, pew,
Bye-bye.
pew.
Yes. All right. Sorry about that. Pew, pew. So where was I? So we're running this test. We want to make sure that container is actually passed into it. I was going to suggest that we run this in debug again, just to make sure the container is being passed into the functions that are being evaluated. So you can see here now that container is actually our injector container, and it's the same one as this. And then so that's going to pass. Well, let's run all of our tests again. Move on to our next test. The next failing test that we've actually, or the next skip test that we've actually got here is this one here. It can instantiate classes that are not registered with it. Now, this is something that's really cool. It's actually really, really quite cool. We're gonna instantiate our injector, and then we're going to ask to see, hey, if I ask the container for just any old class, and I used container class here because it's one that we actually have, I want to make sure I get back an instance of the container class, right? So this if we look at like what we actually want to do, we've covered the lazy evaluation. Now what we want to talk about is creating classes that actually aren't registered with it. This is the really neat kind of part that a lot of people think is actually kind of magic. It's like, you know, I'm asking for this container. We didn't register it with the container here, but even though we ask for it, we still get something back that we can use, right? So let's run this test, and it fails now. So it fails because we get a not registered exception, and that's because the code is doing exactly what we asked it to do. So if we go and we look at the code, and we're saying we're wanting to get, and we were supposed to be getting that container, it says, well, it's not registered, so we're going to throw that exception. So this is actually the area of the code that we need to kind of focus on if we want to be implementing this behavior of our container. So we know that it's not registered, but if it is a class, maybe we can just instantiate that class and send that back, and that'll be enough. So why don't we do that? So we're gonna bury some ifs in here. It's not gonna look pretty to begin with, but we can always refactor once we get something that works. So we're gonna say if class exists that we're looking for, and let's just try returning that. See what happens. Test passes. So now it can instantiate classes that are not registered with it. All right, that was pretty simple. What's the next one that we want to talk about? And the next test is it can resolve dependencies when instantiated classes that are not registered with it. So this is a bit of an interesting one. This test, I wanted to set up a number of different ways. I wanted to run it in a bunch of different, with a bunch of different scenarios. So I used something called the data provider in PHP unit. And so our data provider is going to provide classes to us that we want our container to instantiate that haven't been registered with it. So if we look at this, these are the actual classes that I want our container to be able to instantiate. So I want it to be able to instantiate classes that have no constructor. I want it to be able to instantiate classes that have empty constructors. I want it to be able to instantiate classes that have single dependencies. I want it to be able to instantiate classes that have multiple dependencies. And then I also want it to be able to instantiate classes that have nested dependencies. So we can take a look at these classes and we can see what each one is asking us to do. So no constructor, like I said, has no constructor. So this should just work for us. If we go back, the empty constructor again is a class that just has an empty, it has a construct method, but it's empty. So hopefully again, there's no actual dependencies on this class. So the code that we've written so far should just work. Going back to our test, the single dependency, this is where we're going to run into trouble because we can see that this class actually depends and needs to have another class injected into its constructor. And so it needs a no constructor class. So if we were to run our test right now, I would anticipate that we would get some sort of error from PHP saying, hey, I can't actually instantiate this class because you're not passing in enough parameters to my constructor. Going back at the other classes that we want to be able to instantiate, if we look at multiple dependencies, this one's just like our single dependency, but it just needs two of them. So we've got the empty constructor and the no constructor class that this one actually needs. Finally, the nested dependencies one is really kind of something. So nested dependencies means that you can see here that we've got a class that has multiple dependencies, but one of those classes actually has a dependency itself. So we not only have to construct the dependencies for this class, but in order to get this whole thing to be able to be built, we also have to construct the dependencies for this class so that we can construct it and pass it in too. So there's a lot of work that we're going to have to do. And this is where things get really kind of interesting. So let's run our test, see where we're at so far, and let's get this code to pass, okay? And sure enough, we failed. So when we're looking at the data provider, it did pass with our no constructor data set and our empty constructor data set, but it did fail here. And it failed for the reason that we anticipated, the argument count error. So we weren't passing enough arguments into our single dependency construct method, right? Because we can see that single dependency took this one constructor, this one object in its constructor. And if we go back to our container, not actually passing anything in at all. So that's a problem. So now what we have to do is we have to find out what are the actual dependencies of this class that we know exists, what are its dependencies, and then how do we construct those? And so PHP actually has an API that allows us to introspect classes and get information from them. It's called the Reflection API. It's not very well documented in PHP, but it's been used enough. And it's one of those things that like you're gonna have to read the docs, you're gonna have to read the methods. It's a lot of trial and error, those sorts of things. But it does end up making sense eventually. So let's figure out what are the dependencies of these classes that we're actually trying to construct, and let's do that. So first things first, what we actually have to do is we have to get the reflected class back. So I'm going to create a variable called reflection class, and it's going to be a new, you guessed it, reflection class of our name that we've been asked to construct. Okay. And the reflection class is going to give us back an object that we can then ask to say, hey, give us the constructor of that reflection class. You can see these are all the methods that are available to it. One of them is called getConstructor. And that constructor is going to return, you can see here, something called a reflection method. All right. And then so the reflection method allows then to say, hey, what are the parameters that get passed into this constructor? So we can say at this point, what are our parameters? And that's of our constructor. So it returns the parameters as a reflection parameter object. Okay, so this is going to give us back an array of parameters. So this parameters is actually going to be an array. Once we know what those parameters are, we can iterate over them and we can collect them as dependencies that we're going to be passing into our class here. So what I want to do is I want to create an empty array that we're going to call our dependencies. Now I want to do a for each on our parameters as parameter. And what I want to know from the parameters is what class are you asking for and what position are you actually in this array. Okay, so I'm going to grab the position. So that's another piece of information that we can actually glean off of this parameter object. And that's going to tell us in our constructor. So if we're looking at our single dependency constructor, or maybe multiple dependencies would be a better thing to look at. Which one of these? So this is at position 0, and this is going to be position 1. And so when we get those parameters back and we say, hey, give me the position of this, it will return 0. And when we ask for the position of this parameter, it will return 1. And so that's going to help us populate our dependencies array in the order that we need it, so that when we call our constructor with it, these get filled in the right spots. Okay. And then the other thing that we want to know is the class of that parameter. Class. All right. So now that we have that, I think what we can do is we can add that to our dependencies. So at this point, we can say dependencies equals, dependencies at position is equal to, and we're going to do a little bit of a recursive call here. This get, and we're going to say class name get name, which is the actual name of the class. So that's actually pretty bad. Let's rename this, and we'll call it. I think we can call a class and not have it yell at us. Now that we've got that, we can now return our object, spreading in our dependencies. Okay, and so this is actually going to take this array of dependencies and it's going to pass them into our constructor. So that was a lot of code. Let's see if it works. Hopefully it does. And then we'll step through it once we know that it works, and we can explain a little bit more of the intricacies on like what everything is together through our debugger. Okay, so we're running our tests and it failed. Call to member function get parameters on null. So that's right here. This is where it's failing. And so it's failing. You can instantiate classes that are right here on this data set, something that has no constructor, right? So when we looked at no constructor, we were asking our reflection class to give us the constructor. There's actually nothing here, so it's going to return null. So we need to account for that in our container class, which is right here. So what we can do, again, it's not pretty, but we can just say that if we have the constructor, let's grab those parameters, and then I can do an else. I think that's okay. Else our parameters are going to be an empty array. Okay, it's a lot of code here. Hopefully this works. So outside of that, now when we're looking at it can resolve dependencies when instantiating, we were able to do it with all of those data sets by writing all of this code. Now, one of the things that I want to point out is, like, look at all of this code that we wrote. I mean, there's an opportunity here, I believe, to clean this up a little bit. So we're green, so I think that we should probably take that opportunity to make this code read a little bit better, okay? So the first thing that I can actually see here that gives us an opportunity to clean this code up is this spot here, right? We've got, if we have a constructor, let's get the parameters, else our parameters are an empty array. At the very least, what we can do is we can move this code out of here, right? And say that parameters is an empty array, and that if we actually have our constructor, let's get the parameters, right? So we can remove this else statement, right? It's empty, so we don't need it. And then so we can run our code, and it still should be green, right? I don't think that anything failed at this point. Okay, so that was one small refactor that we could make. Now, this here, right? We can probably extract this just to like, actually, let's talk about this. Why don't we extract this whole chunk of code out of here, this if, into a method that we can kind of work on, and let's call that. So it's a class that doesn't exist, and what we're actually going to be doing is we're going to be building. Why don't we call that build class or something along those lines, right? So let's this is something new. I haven't done this in a while. Build class. Yeah. It's hard to actually, because I'm in display mode. It's so hard to see. This actually says string name, and let me see if I can make this. We'll see what it looks like. We've just extracted this code. So if the class exists, then build the class, right? And we're just going to return that. And build class is down here and it does all that work. And so we just allowed PHP Storm to make that extraction for us. So I feel pretty confident in running the tests, and it should pass for us. And so that was the extract method refactor that we've got. And I think that we can still do better in here. Let me think. We have the parameter. This can probably actually now just be a like a ternary, perhaps. So we could probably say parameters is equal to, we can just say, hey, do we have a constructor? And then if we do have a constructor, let's grab the parameters. Otherwise, let's just use an empty array. And I believe that we can get rid of this. Oops. And now we can run that. All right, so we're still green. Now, the next thing I want to deal with is this chunk of code here where we grab the dependencies for that class. I want to extract this to a method, and let's just call that get dependencies for class or something like that. And so let's refactor that. And now we've got this other method that we allowed PHP Store to create for us, the get dependencies for class, and it's passing in the parameters. As the parameters come in here, I wonder if I'm going to back this out. I think what I might want to do is I might want to just pass the constructor into the. Actually, here, 1 second. Let's go back. Let's make this get dependencies again. So we're going to do that refactor, and let's just make sure that our tests continue to pass, and I believe they will. So our tests are still green. Now we're passing the parameters into here. What I think we could probably do, though, is I think that we could probably just pass the constructor in, and then we can have something like, hey, get the dependencies for this class. Ooh, wait, for class. I wonder if we just pass the whole reflection class in. And then at that point, what have we done? We've actually just, you know what I'm going to do? I don't like that, because I think basically what I would have done is I would have just created a method that just called another method, and then there was just way too much indirection here. I think this is just a poorly named method. So I think what I want to do is I want to rename this to something like get dependencies from parameters. So I'm just gonna rename that method. Or actually, how about just get dependencies, because we're passing the parameters in. That's probably good enough. All right, now that we've got that, I think the last thing that I would like to do, and maybe this is too much, I'm not sure, but we're getting the dependencies here, we're putting them in a variable, and then we're just using them here. So we can probably inline this and then have it like that. That might be enough refactoring for that point. I think I might be happy with it at that spot. And so you can see that we're still green, and we've got now our get method. Now I'm going to give us a little bit more space. Our get method now looks like this. And so again, this is for the part where it can create classes that aren't registered with it, and it can auto wire them together. Okay, so we're almost there. So we're asked to get something that actually isn't registered with our container. So it's not registered, but it is a class that exists. So now what we're going to do is we're just going to say, hey, build that class for us, passing in that name, and then it's going to take care of it from there. So I think that's pretty good. Otherwise, we're going to throw this not registered exception. So I think I like that. I think that looks pretty good. So I think I'm ready to actually move on to the next test that we've got here. So the next test that we've got is it can register callables that aren't evaluated. So you remember we implemented that lazy evaluation, right? That said, hey, I can pass in a function and that function actually isn't going to be evaluated until I ask for it. There might be an opportunity, there might be a time when if I register a function with the container, I actually, when I ask for it, I want that function back. And that could be used for factories or something like that. So right now, there's no way for us to register a function with our container without it saying, without it running that function when it's being asked for. So if we just want to get that function back, there's no way for us to be able to do that right now. So I think what that actually means is we actually have to have a special way of registering a callable, like an anonymous function, with our container. So let's run this test and get it to pass, okay? Because right now it's going to fail. I anticipate it's going to fail because you can see that PHP Storm is telling us there's no method called register callable, right? And so that's actually the reason why it failed, because it doesn't exist yet. So let's just implement that method. And I'm just going to change the parameter names here. So this is going to be the name. And I think callable is probably a good name for this because that's what actually we're doing, registering a callable. Now let's run our tests. And now we're failing because now going back to our failing test, we have another one of these data providers, provides callables. So that's just down here. So the first thing it's going to be providing with us is an anonymous function, which is, this is the PHP 7.4 way of writing a really short function. So this declares a function that returns this is some function. And it's being put into the container at the address of this is some function. So when this gets executed, these are the parameters here that are going to be passed in as our callable and our expected output. So we're going to instantiate our container, and then we're going to register the callable under the name some callable. I guess I was wrong when I said down here, this is what it's going to be registered as. This is the output, some callable. And we're going to register it. And then when we ask for it, we're going to make sure that that's actually what we get back. And right now, what we get back is a not registered exception. And that's because register callable actually isn't doing anything for us, right? So we're not actually registering anything. So even though we're calling it and we're trying to get it, we're getting that not registered exception. So let's fill out the body of this method and make this test pass. So this is actually kind of an interesting idea. When we already have something in our container that says, hey, if this is a function, right? So if we were just to call like this register, for instance, let's just try something here. So if we just call this register name with a callable, it's just, so register callable is now just a proxy to the register method. When we run it, it's going to get caught in this get up here. And it's going to say, yeah, it is actually registered. So I'm going to skip over here, and then I'm going to pull it out of our services array as service, and it is callable. So what I'm going to do is I'm going to invoke that callable and return whatever it gave me back, right? And so we're going to get stuck in there. So if we run this, if we run our code now, it's going to fail, and it's going to say call to undefined function. This is some call to undefined function, this is some function. So if we go back to our test here, the very first callable that we actually registered is a function that returns something called this is some function. So in our test, we're trying to get it out, and then we're trying to invoke it immediately. And so the error that we're getting, call to undefined function, this is some function, is actually this trying to be evaluated. And so it doesn't work for us. But like I was saying, our container already does evaluate functions for us. That's the thing that's actually making this fail. So if we go to register callable, and if we wrap this callable in a function, when we ask for it back, that function is going to be evaluated, and it's going to return the callable that we've got, right? So I think it's a bit of a clever solution that if we do something like this, I think it's going to work for us, because we're effectively wrapping this in a function that returns that function. So if this is kind of throwing you a little bit, like this, this new syntax, it can be something like this: function return function use callable, and then all it does is just return callable, kind of like an identity function. Now, if we run our test, I think it's actually going to pass for us, and sure enough, it does. So let's look at all of the different ways that we were registering callables in this test and seeing how they work, because there's a number of ways that we can actually have callables. So we can have callables as anonymous functions, like this. We can have callables as invocable classes, which are classes that have an invoke method. And then we can have callables as closures. And closures are a special type of object in PHP that are kind of like anonymous functions, but they've got more, I guess, meat to them. And so there's a method called fromCallable that we can actually just pass an anonymous function in and get back a closure. And so those are the three ways that we can actually have callable functions in PHP. There's a couple of other ways, but this is for the most part the ones that we use from day to day. And then so by having our register callable method actually just wrap the callable that's being passed into it in a function itself, we've been able to allow our container to register functions and then ask for them back and get them as functions, which I think is actually pretty cool, if not confusing. So let's move on. We've got one more test here. So this is, here we've got, we just covered registered factory functions. So this is the shared services thing. So this is the example where I said, hey, if we have like a database connection and we don't want to be creating multiple database connections every time we ask our container for the database, we want to share one particular instance of that database connection. This is something that we want. It's a shared service. So we want that thing to kind of be like a singleton. So looking at the test here, we're going to create our container, and then we're going to register. We're going to call a method on there called register shared, which is going to be a new method that is going to say, hey, this is a service that I want shared. So every time that somebody asks for it, I want this same instance back. So we're going to share this instance of our noConstructor class, which when we get it is going to be this noConstructor. So we want to make sure that when we try to get the noConstructor class back, that's an instance that we get back. We don't get back something else. And we want to make sure that every time we ask for it, like here and here, we get the exact same instance back. Okay. So this is, if we run this test here, this is going to fail for us. And it's going to fail because we're calling a method that doesn't exist, this register shared method. So let's just ask PHP Storm to create that method for us. Again, this is going to be our name, and this is going to be our service. Why don't we call it our shared service? That's what it actually is, right? Now, if we run our tests, we're going to get a different error. All right. And then so that's failed asserting that two variables reference the same object. That's actually kind of interesting. Oh, return types. These are got to be void. I don't think that matters, but I missed it in a couple of spots. I asked you guys to catch me on that. Anyways, moving on. So let's take a look at where we're failing. So it's here. So this is kind of neat. Assert instance of noConstructor class. So this is passing. If we register shared, oh, you know why this is passing? This is actually kind of This is because even though it's not registered, because our registered shared isn't doing anything, because of the code that we wrote earlier, where we're able to instantiate classes that aren't actually registered with our container, this is passing. So actually, this is a bad test. This test should have failed here, and it didn't. I don't know. I mean, we're just going to have to accept that right now and keep moving. Maybe there's another way of writing this test, but that's it. So let's make sure that when we ask for it, I guess it is working, but we're getting different ones here. So let's actually have a shared service. Maybe it's not so much of a bad test. Maybe I'm too hard on myself. Let's go to this method here. So this is going to be a weird one, right? We want to incorporate this idea of a shared service. How do we implement that? Because I'm kind of worried about adding additional state to this container. I want to kind of stray away from that. I want to maintain the least amount of state as possible. So I don't want to have kind of like a shared services array or something like that, although that might be a simple approach. I think there might be something else that we could probably do that's going to allow us to have shared services, but kind of keep the same amount of state in the container that we've got. So why don't we just actually do the thing that we're kind of asking for? So why don't we say like something like this register, and then so it's going to be name, and let's just create something called the new shared service. And then let's create a class, and then this is going to accept name and also this shared service thing in it, right? And so if we run this, it's going to fail, and that's because we don't actually have a class called shared service. So I'm gonna create that class. I'm going to put it in our source directory. Thank you for remembering that. And I'm going to say okay. And oh geez, we haven't made a single commit. And so now what I want to do is I'm gonna make these properties. Okay, so let's do that. So we're going to initialize the name and the shared service as properties, and they're private. Now I don't really care too much if they're private or not. So I think actually I'm just going to change these to being public. You know, it's kind of like YOLO life. And this, we're going to have to add, because it's going to be mixed, we're going to have to add some PHP docs for this. So this is going to be mixed shared service. All right. So that's that. So let's run our tests and see where we get to at this point. So we're failing because we failed asserting that injector shared service is an instance of no constructor. So that's here. So now we're failing here. So our test is still failing. Because we registered that shared service, we're not getting that no constructor back because our constructor isn't making one for us. So now let's see if we can deal with this idea of a shared service already. So let's go to the get method. And so it is going to be registered. Let's put another if in here. Let's put it in here, willy-nilly style. So if this service, let's just say if this service is an instance of the shared service, then what I think I want to do is I want to get the shared service out of it, right? And I think at that point, I want to, so that's going to give us back that function that's callable. So actually, I think we're going to steal this code here. Now, I'm focusing on getting it to work at this point. I'm kind of like riffing on an idea. We can always come back and we can always clean this code up. So like if you're cringing at the duplication, those sorts of things, the ifs and this and that, we can get it to work and then we can clean it up. Now that we've got that, I don't want to return that. I just want to make that a shared service. And then after that, I think I can do a this register name as that shared service and then return it, right? And so what I've actually done here is I said, hey, if this service is an instance of our shared service, pull it out. And then if it's callable, invoke it, like let it do its thing, and then capture that shared service. And then let's just clobber the thing that's actually at that name that we've been asked for, which is our shared service, with our evaluated version of that shared service. So that means that every time we ask for it again, we're going to get that same instance back. Let's run our test. I think this is actually going to make it pass. Oh no, failed asserting that closure object is an instance of no constructor. So we're back at the same spot.
Sorry, you're doing is callable on service, not shared service.
Oh, Hossein, I could kiss you on the mouth. Let's see what we got. Oh, we failed again. Function name must be a string. And that's going to be here. Oh, again, shared service. Yeah. Hey, we're green. Oh, sometimes I'm happy with myself. Anyways, so I think we're all green. We looked at what we wanted to do. So we were able to register services. We were able to access those registered services. We were able to access them statically. That's when we did the singleton. We made sure that we supported lazy evaluation. We were able to create classes that actually aren't registered with our container, use reflection to auto-wire those classes together. We were able to make sure that we had the ability to register factory functions and then also register those shared services. But I hope you enjoyed actually watching the code get written and seeing just how powerful PHP Storm actually can be. But I think we can call this GPUG over. Thanks again, everybody, for coming out.